Hello everyone, welcome again. A new wonderful day has begun. We will talking about an interesting and important topic today, K problem solving techniques. Today's module name is Problem Solving and Detailed Innovation for Sustainable Food Solution. As a submodule, we will be covering the topic of explain key problem solving techniques such as brainstorming, root cause analysis, and the use of digital tools to address business challenges. I will provide you with information on these topics as the time permits. First, let's take a general overview of our topics. This module synthesizes food engineering discipline, digital innovation, and corporate resilience on a strategic plan to overcome food waste management challenges. Grounded in the EU Green Deal and the Farm to Work strategy, the course empowers participants with the ability to diagnose chronic insufficiency symptoms and solve root causes using scientific methodologies such as Ishikawa and 5Y techniques and so on. Our learning objective is explain key problem solving techniques, brainstorming, root cause analysis, 5 Whys techniques, and so on. Analyze the distinction between business problem and the surface level symptom to avoid type 3 errors. Identify the technical roles of data analytics. Select the most appropriate process framework, PDSA, DMA, IAC, and so on, and adopt global best practice and behavioral architecture principles, such as Denmark or Nigeria. Okay. Today, I wouldn't just be talking about our wasted future, but rather the engineering discipline that will rescue it. Food engineers are often seen in the lab negotiating with microorganisms. However, today's topic is not just about proteins or enzymes, but how we increase the resilience of our food system. Resilience is the ability of organizations to prepare for, adapt to, and recover rapidly from unexpected crises, supply chain shocks, and shifting market conditions. In food system, resilience aims to maintain operational continuity and minimize waste in the face of climate-related disruption or logistical failures. Strengthened by strategic planning and risk management, this framework ensures that the business not only survives disruptions, but transforms them into opportunities for growth and long-term competitive advantage. The global food system is in complete biological paradox. While we discuss how to feed 10 billion people by 2050, we wasted on third of current production, that's 1.3 billion tons of food. This is not just a logistical error, it's a design failure. Through this presentation, within the framework of Vision Year 2030, we will analyze problem-solving techniques and digital transformation from the perspective of a food strategist. Remember, a waste you cannot measure in the supply chain is just like a fermentation you cannot control in the lab. Both will blow up the system. Let's look at the legal and academic framework. The European Green Deal and its food arm, the Farm to Fork strategy, have transformed food waste from being just a shame into a legal obligation. With the 2025 revision, we now face binding targets that are no joke. A mandatory reduction of 10% in the food processing sector and 30% in retail and consumption is on the horizon. This is where the polluter pays principle comes into play. If you waste food, you are not just losing raw materials. You are also facing carbon taxes and legal sanctions. In academic literature, we call this systematic sustainability, but on the ground, it means don't throw money in the streets. These principles turn the cold, technical data of food engineering into a financial sword. The EU clearly states that business failing to meet these targets by 2030 will have no place in the global value chain. This isn't just a social responsibility project. It's a race for market leadership. Let me tell you our biggest mistake. We often treat the symptom and wonder why the patient still has a fever. High shrink rate rates in the food business are not the problem. They are merely a symptom. When we fail to define the actual problem, we fall into the trap of a type 3 error, perfectly solving the wrong problem. For example, if fruit is spoiling in a warehouse, you might immediately go and buy an expensive cooling system. But if the root cause isn't cooling but inaccurate demand forecasting, that new device will just produce more expensive cold trash. This is why we must use a smart problem statement. Smart problem statement is definitions of a problem based on specific, measurable, achievable, relevant, and time-bound criteria. Rather than vague statements, it provides clear answer to what, how much, when, and where a problem occurs. In pest management, smart statements prevent confusing symptoms with actual problems, type 3 error, ensuring resources are directed effectively. For example, instead of simply reducing waste, it offers a concrete roadmap like reducing technical loss in the milk line by 20% within 6 months. Our goal shouldn't be an emotional sentence like we must reduce waste. It should be a sharp, measurable target like we will reduce technical loss in the milk line from 500 liters to 400 liters daily within 6 months via sensor modernization. This is smart topic. Academic rigor requires examining the problem under a microscope. Now, let's dive into the depths of the human mind, what I call the hidden kitchen of food factories, the concept of psychological safety. Emphasized by Amy Edmondson, is as critical in a food plant as food safety itself. Psychological safety is the shared belief that team members will not be punished or humiliated for making mistakes or offering opposing viewpoints. According to psychologists, this climate is as critical in food plants as food safety itself. When employees feel safe, they can voice equipment failures or process errors without fear or retribution. This transparency prevents sweeping mistakes under the rug, fosters organizational learning, and accelerates identifying root cause of waste, thereby laying the foundation for operational excellence. If an operator is afraid of being scolded for reporting a leaking well, that well will continue to leak and turn thousands of liters of food into waste. Instead of sweeping errors under the rug, we must view them as learning data. Furthermore, cognitive biases are the greatest enemies of food manager. Cognitive biases are systematic patterns of deviation from rational judgment from during decision-making process. It's very important cognitive process. In food management, biases such as confirmation bias, ignoring data that contradicts existing beliefs, or status quo bias, resistance to changing existing systems, obscure the real causes of waste. These mental shortcuts lead managers to reject innovative digital tools or continue faulty process. Awareness of these biases and the development of data-driven strategies are key to objective and effective problem-solving within complex food supply chain. The first, we have been running this line this way for 20 years, is the clearest confession of status quo, bias, and food waste. We must combine analytical and creative thinking. The most important thing I learned during my PhD was that your mind is like a parachute. It only works when it's open. In the fight against food waste, everyone on the team must feel safe enough to say something is wrong here. We know that brainstorming meetings often turn into a competition of who can shout the loudest. Edward de Bono's six think hats technique solved this cause with engineering precision. Six things hat technique is a parallel thinking methodology developed by Edward de Bono that allows the team examine an issue from six distinct perspectives: data, emotion, risk-benefit, creativity, process. By preventing ego clashes, it ensures all stakeholders focus on the same viewpoint simultaneously. In food-based meetings, this technique allows both technical risks and creative valorization ideas. Example, transforming surplus bread into croutons to be objectively evaluated, facilitating balance and comprehensive decision-making for sustainable outcomes. This technique is a parallel thinking methodology that allows the team to look from the same perspective simultaneously. In a project to reduce hotel buffet waste, if everyone follows the black hat and only talks about risk, we get nowhere. But if we put on the white hat to lay out the data, 45 kilograms of bread waste daily, and then use the green hat to generate creative ideas like producing croutons for evening service from surplus bread. That's when we move to circular economy. The blue hat is the conductor managing this whole process. Academically, this is optimization of group dynamics. Personally, I keep the red hat emotion very short in lab meetings. I don't want to hear about anyone's love for wasted products, but sometimes that is necessary to boost morale. Friends, I can tell you that the Ishikawa fishbone diagram is your best friend in the food sector. When a waste incident occurs, if you place the 6M's: manpower, machine, method, material, measurement, environment on the bones, you wouldn't miss the problem is hiding. Pair it with Sakichi Toyoda's 5 Whys technique, and you'll find the true culprit. Imagine that ton of products being destroyed in a poultry plant due to the salmonella contamination. At first glance, the oven is to blame, but as you keep asking why, you might find that the root cause is actually a 30% cut in maintenance staff due to budget constraints. So the technical failure is a result, but strategic budget management is the root cause. This diagram allows you to see the problem in 360 degrees. Engineering is just fixing parts. It's understanding the system. Our slogan, don't just band-aid the wound, treat the infection. So, which tool do we use to fix which problem? You don't attack everything with a hammer. Sometimes you need a surgical scalpel. PDSA, plan, do, check, act. The foundation of the continuous improvement philosophy is perfect for daily rapid operational improvements. Continuous improvement philosophy is the also known as a Kaizen, is an ongoing incremental effort to enhance process efficiency, products or services. Rooted in the PDSA plan, do, check, act cycle, it identifies daily operational inefficiencies in food systems and implements sustainable small-scale solutions. Instead of large-scale overhauls, it focuses on the cumulative impact of daily refinements to minimize waste and maximize quality. The discipline fosters a learning culture within food organization, serving as a vital driver for meeting 2030 sustainable targets and improving long-term operational efficiency. For instance, it's ideal for revising a baker's daily production plan. However, if you want to reduce a chronic 10% breakage rate in a biscuit factory to 2%, you need the DMAIC framework. Six months rigorous statistical discipline. When dealing with human-centered, ambitious problems like why consumers throw food away, design thinking comes in. Design thinking is, it's very important technique, a human-centered innovation methodology. Sometimes design thinking techniques or human design thinking process, you can call it. Design thinking consists of empathizing, defining, identifying, prototyping, and testing phases. In food system, it's specifically used to address behavior-based waste, such as buffet habits or household misengagement. Rather than fixing technical errors, it targets psychological gaps in user interaction. Through low-cost prototyping and rapid feedback loops, it provides creative solutions to complex problems, aligning human behavior with technical process to enhance overall food system resilience and long-term sustainability. Without emphasizing and understanding why a customer forgets food in the back on the fridge, you can't produce a solution. According to our academic metrics, PDSA for speed, DMAIC for precision, and design thinking for innovation. If you chose wrong, it's like trying to shoot a bacterium with a rifle. Let's kick it up a gear. The 8D methodology, a legacy from Ford, is tailor-made for complex, recurring quality defects in the food industry. A systematic 8-discipline framework developed to solve complex and repetitive quality defects such as canning leaks. Instead of focusing on temporary fixes, it targets permanent corrective actions and system updates to ensure the problem never recurs. In the foods industry, 8D involves a multidisciplinary team to identify root causes using statistical data. The resulting organizational learning strengthens quality standards, HACCP, ICO, and enhance operational efficiency by eliminating systematic failures at the core. It shares sealing error in the canning line. An 8D team is formed. Interim barriers are set. The root cause is found and the system is updated. Then there is a Elio Goldratt's theory of constraints, which is my favorite. Theory of constraints, talk, a management philosophy based on the premise that the success of any system, production line of supply chain, is limited by its weakest link or bottleneck. Failure to manage bottlenecks in food business leads to product spoilage and waste during wait times. For instance, in a milk plant with a slow bottling line, all process must be subordinated to the bottleneck speed to prevent raw milk waste. TOP focuses on identifying and improving these constraints to increase throughput and reduce inventory cost. A system is only strong as its weakest link. Remember, the milk processing example, if you have plenty of milk but your bottling line is slow, the bottleneck, that milk spoils while waiting in tanks. The solution is to subordinate milk reception to the bottleneck. If you don't manage the constraint, you just accumulate more waste. Digitalization is no longer just source for the food sector. It's the main cause itself. Thanks to AI sensors, we can see in real time when a banana switches during transport. Artificial intelligence (AI) processes data for us and predicts the future. Look the IKEA example. It's magnificent. Using the Vino Vision AI system with the smart bins, they analyze when food was wasted and why, reducing waste by 54%. Rescuing 20 million meals is a massive economic and environmental victory. Also, some retailers reduce waste by 39% using dynamic pricing algorithms that lower prices as products approach their expiration date. As a professionals, we don't food with data analytics. Data is a new oil, but we refine to keep food fresh. Trust and transparency are the foundations of food systems. Blockchain technology records the journey of food from farm to fork in an immutable digital ledger. The Walmart and IBM Food Trust collaboration is the most concrete example. They reduced mango traceability with 7 days to 2.2 seconds. Do you know what the means? In a food safety crisis, instead of destroying tons of safe products, only the problematic ones are found in seconds. This is the digital prevention of waste. The Fazla platform from Turkey is also a point of pride. They rescued four, four 40,000 tons of food through AI-supported operations. Traceability is no longer a luxury. It's a technical necessity for food safety and waste management. Problem solving isn't just engineering. Sometimes it's a psychological architecture. The Stop Wasting Food movement in Denmark started by Selina Juul. Selina Juul is a prominent figure in the global fight against food waste, notably through her Stop Spoil of Met, Stop Wasting Food movement founded in Denmark in 2008. Her relentless advocacy led to a remarkable 25% reduction in national food waste within just a few years. They reduced waste by 25% in 5 years. How? So it's simple. Behavioral architecture. They removed quantity discounts like buy 3 for the price of 2. Then, when people didn't buy extra food they didn't need, household waste decreased. Another example is cold hubs in Nigeria. Reduces harvest losses by 80% with solar-powered cold rooms. Cold Hub, founded by Nnamdi Nwosi in Nigeria, offers an innovative solution to logistical and storage challenges through solar-powered plug-and-play cold rooms in regions where up to 40% of fresh produce is lost due to the lack of cold chain infrastructure. These modular hubs extended the shelf life crops from 2 days to 21 days. Beyond being a technological feat, Cold Hub serves as a functional design masterpiece that boosts the income of small-scale farmers and strengthens local food security by minimizing post-harvest loss. In conclusion, looking toward 2050, our vision is clear: a climate neutral future. Reducing food waste is the fastest way to cut global emissions by 10% and feed 870 million hungry people. All these tools were discussed, from AI to blockchain, from Ishikawa to design thinking, actually serve one thing: holistic ecosystem management. As professionals, we are not just technicians extending shelf life. We are strategists managing the planet's resources. Every step we take today guarantees the food security of future generations. Remember, food waste is not a result, but an indicator of bad design. Let's redesign the system together. Thank you for your participation and patience. If you have any question, I'm waiting your question via email. See you next topic.